In this problem, we are given the picture so we don't have to draw it, and what we're asked to do is try to find the largest area of a rectangle that is inscribed inside of a triangle. It's an isosceles right triangle whose hypotenuse is 2 units long. So the isosceles right triangle, we put the vertex on the y-axis and our equal legs coming down, hitting the x-axis so that the hypotenuse is 2. That would make this point right here 1. This point is 1. And that makes the hypotenuse 2. And then we've got some other things that we should look at. It's isosceles right triangle, so this is 45 degrees right here. This is 45 degrees right here. And because of the 90, the other two have to be 45, and isosceles right. And on top of that, we have, if this is 45, and we have a 90-degree angle right here, we now also know that this angle here is 45. And so we have another isosceles right triangle here, 45, 45, 90. And that will allow us to find the equation of this line right here. And the reason we need to find the equation of the line is we have to get the dimensions of this rectangle, which means not only do we need to know the length of the rectangle, but we have to know the height. Now, what's the length of the rectangle? Well, we'll let x equal the distance from the origin out to this right side of the rectangle. And if that is x, then the height of this rectangle will be a point on this line. And so that would be f of x for the function of the line. So we need the equation of the line. It's going to be pretty easy to get. We have the y-intercept is 1, and the slope is, we are going down 1 and over 1, so the slope is -1, so our equation is negative x plus 1 for the equation of that line right there. And so that ordered pair P is going to be the point x comma 1 minus x. So now the area of my rectangle, a of x, will be 2x because the distance across the rectangle, we have x on this side, so that means we'll have x units to the left as well. So that'll be 2x for the base of the rectangle, and then the height of the rectangle is 1 minus x. If I multiply that out, I get 2x minus 2x squared, which makes the derivative very easy to take. A prime of x will be 2 minus 4x. And if I set the derivative equal to 0, I will easily get, I got 4x equal to 2, and x will equal 1/2. So that is my critical point. Derivative will exist everywhere. Our domain for x will be from 0 to 1. It has to be actually greater than 0. It has to be less than 1. But we'll use those as endpoints. That will make it very easy, because we can say that a of 0 is equal to 0 when we plug in a 0 into our area formula. If you put a 0 in, you'll get 0, and then we're going to plug in a 1, and you're also going to get 0. 1 minus 1 is 0. So a of 1 is also equal to 0. And then our critical point, a of 1/2, will equal 2 times 1/2 times 1 minus 1/2, which is 1/2. So you'll end up with 2 times 1/2 times 1/2, which is 2/4 or 1/2. So our area will be 1/2 when we have our critical point of 1/2. So that means we can now make our conclusion. The largest area that our rectangle can have is going to be 1/2 square units when the dimensions are 2x, which is going to be 2 times 1/2, which is 1, by 1 minus x, which is 1/2. And they didn't give us any units, so we'll just say 1 by 1/2 units. The justification, we do not need to use the first or second derivative test because we found all the critical points and endpoints, and we found the largest value is when x is equal to half.